The second method that we're going to look at to find the roots of equation is called Newton's method. And it's also called Newton-Raphson method, and again it's very widely used. And in this method what we're going to do is take the slope of a function and calculate that at whatever your initial guess value is and project that down to the x-axis. We'll show that graphically here in just a moment. And where you find the slope intersects with the x-axis, that becomes your new guess value, and you keep doing that until you get the answer to the specified tolerance that you want. So again, illustrating it here, here's a function, and you can see over here this is where the root that we're trying to find, but maybe we make an initial guess and it's here. Well, we can calculate what the function, the value of the function is at that initial guess, but we can also calculate what the slope is. And so if we project the slope down to the x-axis, where that intersects is going to be the new guess value. And so if we take the slope and divide it by the y at x initial and subtract that from x initial, that becomes our new guess, x new we've called it. And then we keep doing that until we get closer and closer to this actual value right here, this root. So let's look at an example. Here's a third order polynomial, and we want to find a root. As you could probably guess, there may be more than one root for a polynomial like this. And we can also take the derivative of that equation. And so there's our value of y prime. And we'll make an initial guess value. Just arbitrarily, we'll pick 10 as being our initial guess. Okay, so for x equals 10, we calculate y, and we calculate y prime. We take y divided by y prime and subtract that from the initial value of 10, and we come up with a new guess of 7.6724. That's our newest value. Now let's show that. Here is the equation plotted. And so if our first guess was 10, we calculate again y and y prime. We project the line with the slope equal to y prime, and where that crosses the x-axis, that becomes our new guess value, 7.6724. One more step. Again, we calculate y. We calculate y prime based on this new value of x. We take that value of x and subtract y divided by the slope, and we come up with a value of 6.35. So that becomes our guess for the next iteration. And so again, showing that, it was after the first iteration, that was our value of x. We calculated y and y prime. We project a line with the slope of y prime, and where we've intersected, this becomes our new guess value, 6.35. So you can see we're getting close to this actual root right here pretty quickly in a couple of iterations. And if we continue that, you can see it took very few iterations to get down to the root of 5.6577, out to 4 decimal places anyway. Now if you put in different guess values, you're going to get different results in this case, because as we know, this is a third order polynomial, and it turns out that there are 3 real roots for this one. So depending on what initial value you put in, will tell you what root you're going to come up with. And so again, here are the 3 roots that we found based on the guess values that we did. And we'll emphasize this as we go along. A lot of times making the plot is a good first step. If you make the plot, you can see that where those roots were at about -2, +2, and 6, say, if you use those as initial guess values, you'll make sure that you're finding all of the roots in this polynomial. We'll also see in MATLAB there is a tool that will find all the roots of a polynomial, but we'll do that next time.